This question is definitely about exponents, but it's also about factoring and foiling, right? Those two operations where we have like either distribution, so it's not technically foiling, but distribution or factoring something out. Now, I think whenever we have an algebra question, it's important to remember that there are sometimes, especially when there's answer choices, two directions that we can move through the question. And you should be consciously thinking about which way is the easier direction. So do I want to take what I have here and factor out some number? I think that's risky. It's a division problem, basically, and division is kind of annoying. Whereas multiplication, distribution, that's more simple and more straightforward and something you do more often. So I would go to the answer choices and try to think about how distributing is going to get us the answer that we started with, right? The initial expression. So I can already tell that in A and B, we're not going to get the two terms that we need, right? So there's no way to kind of condense this thing into one term. The reason being that the exponents on the x's are different, right? So yes, there is a similar y exponent, y squared, but it's the combination of the x and the y is what determines like the species of number that we have, the type of thing. We can't combine these because they need to have the exact same combinations of x's and y's in order to add them together. So we can't do that, but we can think about that distribution. Now, to me, the easier thing is the end, right? Because it's just what's getting multiplied by 2. Well, the 6 would be multiplied by 2, and then we need an x squared, y squared. So, okay, that actually checks out for both of them. So that's no issue. So now it really comes down to this, the 6 and the 4. And this is where most people are going to mess it up because for whatever reason, we're thinking we're multiplying. So we really want that 8 to come about by doing 2 times 4. But when we multiply here, we have to remember that the x's are already multiplying. So what happens is when we multiply things, we actually end up adding the exponents, right? So remember, with exponent rules, everything gets shifted, right? So if you want to do multiplication, you shift down 2. You actually end up adding the exponents. So x squared plus x to the 4th would only get me an x to the 6th. Here, though, x squared plus x to the 6th is the x to the 8th that I want. And I should be clear, I'm saying this wrong. I'm not adding x squared and x to the 6th. I'm multiplying x squared and x to the 6th. What ends up happening then is that the exponent gets added, right? So I am multiplying the bases, right? So this is for the bases, but then this addition is for the exponent. So anything you want to do with exponents, we shift down 2 in our germ dots or order of operations, and that tells us what to do to the exponents. We are still doing multiplication to the bases, and that's why we end up with x to the 8th, right? Because what does that mean? That means 8x's all multiplied together. X times 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 x, right? And so when we have 2 of them getting multiplied by 6, that's now 8x's all getting multiplied together. So that's kind of where it comes from. Hopefully that makes sense. It is very difficult to talk about exponents because we're kind of in this weird realm of kind of overlap where an exponent is short for multiplication, but then we end up doing a lot of other things like adding when we do it. So it kind of feels like we're kind of transcending the different types of operations, but that's why I think about this germ dots really helps me is we're shifting down 2, and that's what we do the exponent. So hopefully that helps you here.